we are talking about the least mainstream thing that Nordic does, which in my opinion is actually the most disruptive thing that we're doing.
In terms of PMIC, in terms of its intelligence, it's interfacing with the SoC to understand the point at which the battery is going to lose data, and it steps in and makes sure beforehand the SoC knows that it's going to lose its power and says to the SoC, save the data.
That's one of about 7 things that's amazing about this one.
Hello ipXchange. We're all about disruptive technology. I'm on a non-disruptive technology booth at CES, Nordic Semiconductor. Not normally the type of area that we would normally cover, but my good friend, new friend here, Finn, is going to tell me how they have a very disruptive PMIC. So over to you, Finn. Tell us why a mainstream semiconductor company at CES is disrupting the world.
Okay, so as you wanted to hear, we are talking about the least mainstream thing that Nordic does, which in my opinion is actually the most disruptive thing that we're doing.
Excellent.
Because Nordic is mostly known for doing low power wireless, right?
Yes.
The most horrible thing you can do to a low power wireless SoC is put a very bad PMIC in front of it, because then the whole thing isn't low power anymore.
Right.
So what we are doing here, or what we are showing here, is our newest PMIC. It's the nPM1300, and this one does.
You said that very quickly. Just say it again.
nPM, Nordic Power Management 1300.
Even I can work that out. Yeah.
Yeah. So this is the EK. The nice thing about this is it has several nice things. The first thing is we have a really nice program that runs on the PC, graphical user interface. You don't need to write a single line of code, everything works. But the part itself does a lot more than a PMIC. So it has fuel gauging, so it basically works like a coulomb counter, but it's not a coulomb counter, which means it runs in software. It's using a sophisticated algorithm that we wrote, which means it's using less power. It runs in software, and it has several nice features that make it work better with our SoCs.
Right.
So for example, yes.
So this is just so that we're clear. This is specifically designed to sit next to your SoC.
Yes and no. That's the main use case. You can use it for others. It's gonna run most likely. It's gonna run better with our SoCs, because that's what we designed it for.
Yeah. Okay.
I'm not saying you can't use it without. I'm just saying that's the main use case.
Yeah.
One of the other really cool things we can do is you can get a battery model. So one of the things you always want to do for batteries is you want to know the state of charge. Right? If I take my device and I have a battery, a lot of the time what you're going to do is you're just going to figure out how full the battery is based on the voltage.
Yeah, very simple.
Yeah, and that
analytics.
sucks. Because if you actually want to know the state of charge, and you take that battery from in here to outside where it's like 10-20 degrees colder, it's going to say your battery is basically empty just because the temperature is down, which drains the voltage.
Yep.
So we wrote an algorithm that fixes that. And we also can do the battery model with this kit. So you can take your battery, you can run the battery, drain it, do the same thing, put the kit in a fridge, do the same thing, drain the battery again, then put it into, well, let's say an oven that you have at 70 degrees, like whatever the maximum temperature is your device run it. Run the same thing again, and then you have a really accurate model that gives you very accurate battery stage of charge, no matter like where your device is. So it's going to work the same inside, it's going to work the same outside. It's like way more accurate than anything else you can get. And this has, like, that's what I mentioned, like, this is actually disruptive because this has so many cool features just on one SoC. So for example, on one PMIC.
PMIC, yeah.
So you have, let's say you have a normal SoC and has something like a brownout detection, right? Power loss warning. Usually what you would want to do then is like save the bit of data you have in a safe state.
Yep.
But if the power is already that low that the IC notices it, it's actually too late. So here we have it externally. When we notice the battery is disconnected, since we have it external, not on the SoC, you actually notice it a tiny bit earlier, which means you have time to save data. For example, the data you have in RAM, save it down to the flash to save something. Another thing we're doing is we actually have GPIOs on the PMIC. So a lot of the newer technologies, we're going down in process technology, which means they're not running on 5 volts anymore. So you don't have GPIOs that run on 5 volts. That's another feature that we did, for example. We have 5-volt GPIOs on this PMIC for the SoCs that don't have 5 volts anymore. So like lots of really cool features on here.
You've done a lot of talking there.
Yeah, sorry. But as I mentioned, like this is a really interesting thing.
It is, yeah. So if today I'm trying to manage that battery,
yeah,
and I don't have that, what would I have instead?
You would have not. It depends on which of the features you would have. You would probably have like 3 or 4 different discrete ICs.
But the most powerful thing that you're saying about this PMIC is it's intelligent.
Yes.
That's what you're actually saying.
Yeah.
So is it fair enough to say that most power management ICs aren't intelligent and they just respond to, they're just doing the job that they're being asked to do?
Most of them are discrete components.
Yeah, they're just discrete.
Do like one
they're just
thing.
doing the job that they're asking. So you have put software in there.
Well, we've put software in the SoC that's communicating with us. So this
so it is a relationship between
Yes.
the SoC and the PMIC.
Yeah.
So really, you can't really use it unless you're using a Nordic SoC.
Well, if you're using it on a non-Nordic SoC, we will give you the binary to run the same thing on a different IC.
Yeah.
But we will not give you the source code.
Right. Okay. So the reason why this is disruptive is it true to say that in terms of PMICs, in terms of its intelligence, which is the thing that you've just talked about, it's actually it's interfacing with the SoC to understand the point at which the battery is going to lose data, and it steps in and makes sure beforehand the SoC knows that it's going to lose its power and says to the SoC, save the data.
That's one of about 7 things that's amazing about this one. But yes, that is one.
I think I'm very impressed that I've just remembered one. So just go over the other 3.
Okay, so
We don't need all 7. 3 will do.
Like the main one is actually the battery state of charge, so the fuel gauging. So you can actually you can basically count electrons that are going out of the battery. So you can get very accurate state of charge in the battery.
But most PMICs will do.
No, if you want to do that nowadays, you will get like a dedicated coulomb counter, and that's gonna count like the electrons that go from the battery out. If not, what you're doing most of the time, if you want to see the battery state of charge, you're basically doing you're measuring the voltage, and you have your lookup table, and that's gonna tell you I'm like 40% full, and that works if you always run at the room temperature.
Oh.
If you don't, it doesn't.
Yep, you did say that. You did say that.
I know.
Yeah, okay.
And the other one is actually like, usually if you have a PMIC and it does more than one thing, you need to set it up, you need to set parameters, you need to make it work, you need to write some code.
Yeah.
Here we actually what we see behind us actually the graphical user interface for our npm power up app, which you can use to set all the parameters. You can export that as a JSON file, get it into our development environment, put it into the SoC that next to it, and you don't need to write code to make the PMIC work.
Right.
So that's 3 things to keep in mind.
Okay, so I mean, most people would say PMIC is a pretty standard technology. Get PMICs from anywhere.
Yes.
Yeah. So you've come along, and basically you've come along because of the low power wireless, and recognise the fact that you need a PMIC to sit next to your SoC.
Yeah. So the idea for us we want to control the complete power path from the battery all the way to the antenna.
Yes.
And now we've gotten the itsy bitsy piece in between the battery and our SoC.
Okay.
And that's where PMICs come in.
Right. So obviously, obvious applications for this are IoT applications, wireless applications. This is a dev board that a engineer can go and get.
Yes. Yes.
Good. And does that cost them money, or what sort of volumes would you give one of our members access to that board?
Well, the board itself is quite cheap. I think it's like a couple of dollars.
Is that a couple of dollars? Right. Okay.
Yeah, it's a PMIC.
I know.
It's not too much. No, all of our boards are affordable. Like even the 50 to 840 board you can get for like $20 to $30.
Right. Okay.
So like we don't make $200 boards. Well, we make one, but that's because it's actually that expensive to make.
Okay.
So we don't earn money on our hardware. We just sell all of our development kits at cost, because that's not how we make money. We sell chips.
I understand. understand. Very good. So we have found on our very last interview at the first day of CES, what we probably wouldn't have expected is to walk onto Nordic Semiconductor and find a disruptive PMIC. That wouldn't have been how I started my day, but it's how I've ended it. So Finn, thank you very much.
Thank you.
Very, very good explanation.